IIT Lucknow. I have worked in the area of wireless sensor networks, IoT, and machine learning for quite some time now. So today, for today's session, I will be discussing IoT and smart city. I will start with some of the fundamental concepts of IoT, which have paved the path for the concept of the smart city, as we know. But before, okay, just I'll turn off my video now so that it is not distracting. Just a minute. Okay. Okay. It's great. So okay, so the organization of this presentation is presented in this slide, and as reflected here in this slide, you can see that we shall start with a brief introduction of IoT, the fundamental building blocks, that is sensor nodes, and we'll cover the evolution of IoT as well. I'll try to explain the need of IoT and why IoT is required, which will be followed by some of the basic challenges which we face in the era of Internet of Things and smart cities. I'll also discuss some of the IoT architectures, which will be followed by the concepts and goals of the smart city as well. I will discuss the important differences between sustainable and smart models and the role of information and communication technology in the growth of the smart city concept. We shall also see two use cases, specifically of a smart parking and a smart transportation system, and we shall also try to cover the layered architecture of smart cities. So basically we'll be covering three architectures: two general purpose architectures for IoT, and one architecture for layered architecture for smart cities. And if the time permits, I will also try to address event detection problem of in which is a very popular research problem in surveillance systems, and it is a very integral part of smart cities as well. Before concluding the session, so let us start the session with the backbone or the fundamentals of IoTs, that is sensors, and from which the Internet of Things has evolved, that is a wireless sensor network. Now, to explain the Internet of Things and what Internet of Things is and why IoT is needed, let us have a brief introduction about wireless sensor networks. So basically, wireless sensor networks are ad hoc distribution of sensors. When I say ad hoc, I mean to say that the nodes are deployed in random areas, like whatever, depending upon the application, the nodes can be deployed in certain areas. The objective of these sensor nodes is to sense and report the events for which they have been deployed. Now, considering that these nodes are battery powered, and they have limited communication range, limited sensing range, and all these things, it might not be possible for every node to communicate directly to the sink, and hence they cooperate with each other. They share information, they share knowledge, they share the data with each other, with the hope that the data is finally reported to the sink. Now, this cooperation between the sensor nodes forms a transmission path from the actually sensing the event to the base station. Now, this information which is sensed by the node or perceived by the node is reported to the sink, and at the sink, the data is analyzed and processed to obtain the relevant informations. Now, such applications of wireless sensor networks are very popular. They are popular in environmental monitoring. They are popular in defense systems. They are popular in our day-to-day life as well. But what I would like to highlight here is, as you can imagine, the amount of data which is being generated. Now, the amount of data which is being generated becomes quite obvious is from the fact that once consider a network of 10 sensor nodes and multiple events are happening simultaneously. So what happens is once let us say the first event is sensed and reported by a single one of the nodes, it is being reported simultaneously. Two or three or five or 10 or more than 10 events are occurring. Now, considering that multiple events are occurring simultaneously, all these events are being reported by one or the other sensor node to this thing. Now, this generates huge volume of data. This generates huge volume of in-network transmissions, and to process this huge amount of data, to process this huge amount of in-network transmissions, obviously the sensor nodes initially present in the market, for instance, in the the nodes which were present in the market 5 years or 10 years back, they had limited computational capability. Now we have some advanced nodes, but then again, the computational and the processing abilities of these nodes are limited. They have been upgraded, but still limited. So to process this huge amount of information, to process this huge amount of data, uh, uh, some algorithms, some methods, some mechanisms are required. Now, even if that is at the sink, that is a different concern. If that is at the node, that is a different concern. But the idea is that the huge amount of data is being generated, and this data has to be processed, because the since the data is being reported from the nodes to the base station, and if we are unable to process this data, if we are unable to make meaningful observations out of this data, the entire idea of sensing and reporting the event goes becomes obsolete. So it is better to it is always required to process the data and get meaningful observations. Now, while addressing the issues of wireless sensor networks, or while addressing the different concerns of wireless sensor networks, there are some of the basic fundamental requirements of any wireless sensor network. That is, as I said, the sensor nodes are battery operated, and hence they have limited lifetime. They have limited communication ability. They have limited processing ability. So these things are to be addressed while discussing any application of wireless sensor networks. And while addressing any of these issues, the general objective of any solution or any research problem while working with wireless sensor networks is, first one would be the lifetime maximization. And how this can be done? This can be done by, maybe one of the approaches is network load distribution. So the lifetime maximization of the network is a primary concern and should always be dealt while discussing or while addressing the issues of wireless sensor networks. Now, coming to the concept of IoT, if we see the definition of IoT, it is the name of the this technology is enough to describe what this technology is about: Internet of Things, which describes the a network of physical objects. Right? Network of physical objects means that this things, Internet of Things, is what things is, which are embedded sensors or embedded softwares or similar technology of connecting and exchanging data with other devices. And that might be other devices or the other systems, and these are connected over the internet for the exchange of data. Now, if you want to have if you want to see a example of a Internet of Things, that can be a a very simple thing, such as a light bulb, which can be switched on from a mobile app, and it ranges from over there to smart homes, to smart cars, smart refrigerators, smart ACs, smart mirrors, And from all these basic concepts and from all these basic applications of Internet of Things, this can quickly grow to technologies such as smart cities, smart grid, and smart transportation, and all these things. So Internet of Things have evolved over the past years with the because why it has evolved, because of the advent of this technology. The wireless sensor networks was the foundation on which it has been evolved. But yes, in the past years, the IoT has progressed seriously. And as you can see in the graph over here, the number of users of mobile technology or internet and communication technologies, I would say, or information and communication technology has significantly grown. So the very natural question which arises is that why technology, why Internet of Things, or what technologies have made the IoT possible? Why now? Why IoT is becoming a popular concept as of now? Now, to answer this basic question, we have to acknowledge the fact that IoT has been in existence for a long time, and a collection of recent advances, not only one advance in a specific field or two advances in some totally different field. It is not like that. The idea is that the collection of recent advances, all some advances in some of the fields, some advances in some other fields, and all these advances when combined together, so this has resulted in the growth of IoT. So a collection, when I say a collection of recent advances, then that means that these advances in more than one field, not only in the field of wireless sensor network, not only in the field of image processing, not only in the field of pattern recognition, not only in the field of machine learning, not only in the field of deep learning, not only in the field of artificial intelligence, but some small advances, some major advances, and some all these advances when combined together in a different number of technologies have made it possible for the IoT to grow significantly. Now, for instance, if I talk about an example, then let us talk about the access to the fundamental building blocks of the Internet of Things. That is the sensors, right? So, if we talk about the access to the low cost and low power sensor technology, then since the sensors are now more reliable and more affordable, more applications of the technology are of this IoT are coming into light every day. So that is a quite obvious fact. Now, to some other important changes can be considered in the connectivity as well. Now, connectivity means the connectivity of the devices. Now, much efficient network protocols for the internet have made the connectivity of the sensors to the cloud a much easier concept as it was 5 or 10 years back. Another important concept in this, which has paved or which has constructed the path for the growth of IoT, is the introduction of machine learning and data analytics into this concept, into the concept of Internet of Things. As I have already discussed, that the amount of data which is being generated is significantly very high. So, considering the amount of data being generated and the processing and the analytics required for all the data which is being generated, now machine learning has one of the most important and most in influencing machine learning has been one of the most influencing factors in the growth of the Internet of Things technology. Similarly, if I talk about neural networks, then the use of neural networks or artificial intelligence techniques have made the Internet of Things daily name in the in even in my home, in your home, and in every household. Talk about the technologies such as Siri or Alexa. They are one. They are taking one or the other advantage of IoT and artificial intelligence for making things possible for us in our day-to-day life. Now, taking the IoT technology to the, if we take this IoT technology to industrial applications, where it is referred as industrial IoT, the impact of IoT has been phenomenal in that field as well. The use of machine-to-machine communication and with cloud technologies and technologies of machine learning, neural network, all these things combined together have made industrial IoT one of the most popular choices for not only for innovators but also for researchers, for entrepreneurs, and for so many people. Now, among the many common uses of industrial IoT, few of them can be considered as smart manufacturing or smart power grids or even smart cities. We shall be discussing a smart city in a bit. But then again, these technologies have paved the path for the growth of IoT, and we have some challenges in IoT. Now, these challenges need to be addressed, as because all said and done, there are some basic challenges that need to be addressed, and some of these challenges are the some of the common issues such as scalability, security, privacy, and some of the challenges associated due to data analytics. Now, these challenges need to be addressed by all IoT applications and architectures. Now, when I say architectures, today I shall be discussing architectures. The one of the two architectures which I'm going to discuss is the architecture which you can see on the screen, that is one M2M architecture. Now, one M2M architecture, machine architecture. This is one of the earlier architectures which was proposed in the early years of the evolution. Now, the idea, this architecture was proposed with the aim of standardizing the rapidly growing machine-to-machine communication. Right, this one machine-to-machine architecture was developed or was proposed in a joint collaboration of Cisco and some of the other big names in this area. So this was proposed to standardize the communication between machine and machine. Now, as evident from the figure over here, you can see the figure over here. In this slide, there are three major domains of this architecture. The application layer, which is shown over here, the services layer, which is shown over here, and finally the network layer. Now, targeting the connectivity between the devices and their applications, the application layer is responsible for these kind of operations, which are responsible for connectivity between the devices and their applications. So, the application layer basically facilitates these features. Now, applications can have their own data models, and one can interact with different APIs with the help of different application layer protocols. The next layer of this architecture is the services layer. Now, the services layer is where the physical network and the IoT application, the physical network on which these IoT applications run is present, and all the related management protocols are addressed in this layer. So basically, the idea is that this layer is there to add APIs and middleware supporting the third-party services and applications. Finally, the communication domain for the IoT devices and the endpoints is managed by the network layer. It includes the devices themselves and the communication network that connects them or that links them together. The second architecture which I'm about to discuss is the IoT reference model. This is the IoT reference model. It was published. Published by the IoT World Forum, and it is a very simple architecture. As you can see, there are 7 layers or 7 levels in this. It is also known as IoT World Forum Standardized Architecture. Now, this is, as you can see in the figure over here, the architecture is very simple. It is a seven-layered architecture. This IoT architectural reference model with each of the seven layers offers specific functions and security to the entire model. Okay. So I'll go through these layers one by one so that the concept of all these layers and the functionalities of all these layers can be addressed. So as I said, in the first layer, you can see over here the physical devices and controllers. The first layer is this is the first layer which is to be addressed. This layer is considered as the home of the things in the IoT, Internet of Things, you can see. And it includes various endpoint devices and sensors that sense and send the information from the ground level to the processing. Now the next layer you can see over here is okay. So we were discussing this, the physical devices and control layer. Now this, as I said, this is the layer which includes various endpoint devices and the sensors which can send the information. The second layer, which is the connectivity layer. Now, as the name of this layer suggests, it is responsible for the connectivity. Now, what do you mean by connectivity? Now, connectivity is required for reliable and timely transmission of the data. So, the functionality of this layer ensures this layer ensures the connectivity between the devices, between different devices, and also between the different layers of this architecture. Now the third layer, which is the edge computing layer.
Yeah.
The third layer.
8-49.
Yes.
సార్ అది ఎప్పుడు నేను 2016లో వేరే ఏరియాలో తీసుకున్నాను సార్ హై స్కూల్ రోడ్లో.
Sorry, I cannot hear.
సారీ
ప్లీజ్
పెడుతున్నా రౌటర్ లేదు సార్ అది.
Hemant Kumar, I guess. Hemant Kumar Gaddi, please mute your mic.
Dr. Vishal?
Sir.
I think somebody is asking question probably.
Okay. Our voice is not clear. Hemant, please go ahead.
No, sir. He is speaking with some other person, not a question, sir. You can continue, sir.
Okay. Continue.
Okay. So, okay. As I was saying, the third layer in this IoT reference model or the reference architecture which we are talking, the third layer is the edge computing layer. Now you can see the edge computing layer is basically the primary goal of this edge computing layer is the data reduction and the converting the network data flows and information, whatever data has been received, that has to be converted, that has to be processed in such a way that it can be it is ready for storage. It is ready for storage and it is ready for processing for all these layers above this layer. So this edge computing layer is responsible for this data reduction, data processing, and all this. Now all these layers, starting from the layers 4 to 7, these layers are called upper layer. So basically the edge computing layer processes the data for all these layers which are present in the layer 4, layer 5, layer 6, and layer 7. So These layers, the layer 4, 5, 6, and 7 are called upper layer, and basically I'll not go into the details of this, but again, these layers 4, 5, 6, and 7 are basically responsible for handling and processing the data which are generated by the layers below at the below level. So, having discussed these two prominent architectures of IoT, let us discuss some of the one of the most popular application and concept where IoT is being heavily used. Now, this concept which I'm going to discuss next is the concept of a smart city. What is the concept of how IoT is used, and what are the definitions, what are the goals, and all these things. So as we can see, as we are seeing in our today's world that that the urban population is significantly growing, and that too at a tremendous speed. Now, the resources of any city, of any the infrastructure or the resources available to any city are basically limited, right? But because of this tremendous growth in the urban population, and that too at a rapid speed. Now, what has happened is that these resources are getting adversely affected. Now, the building blocks of the city, for instance, the building block of the city infrastructure, such as the roads, the traffic system, the availability of water, the sanitization of the entire city, all these are getting adversely affected. The roads, we are seeing in our day to day life that we are facing the traffic jams, and long number of vehicles in a queue whenever we go to a big market or supermarket. We have to face all these issues on a daily basis. Now, why this has happened? This has happened because the number of people which the city was originally, which the infrastructure was originally planned with, is growing tremendously. Now, as the number of these people utilizing these resources are growing, however, the number of people using these resources have grown, but the resources are stuck at that point only. And these resources are functioning to their maximum capacity, and that to 24 cross 7 and 365 days a year. Now, in order to cater the needs of the fundamental needs of of any city, the basic necessities of any city, what are the basic necessities of any city? These are clean water, clean surroundings, clean habitat, and all such issues which are not very complex issues, which we should be considered while planning a city. But then again, considering the resources and considering the amount of people which are already present in, so these are the basic facilities or basic necessities which need to be provided to every citizen of the city or the country or the state or whatever. So, but the idea is that these services are to be provided, but with that too, if we can utilize the information and communication technology, if we can utilize the resources of the information and communication technology without imposing any extra overhead on the natural conditions, for example, without imposing any extra overhead on the without uh, without adversely affecting the natural habitat. This is what the basically what a smart city is all about. So, as you can see, the definition of the smart city, which is shown over here, is the working definition. From the working definition, it is quite clear that a smart city involves human beings, the infrastructure, the information and communication technology, and the idea is to provide the basic or the necessities of a human life. Now, to understand it clearly, it is basically this definition. If you can see, this definition is basically utilizing these scalable solutions, which involves human and communication technology. And human and communication technology means humans are also involved, and the information and communication technology, which we are already witnessing, that is also involved. Now, the use of scalable solutions, information and communication technology, to what end? To what end we are using this? To what end? Then the idea is to either to minimize or remove the issues which the urban world or these cities are facing in a cost-effective, reliable, and efficient way in order to improve the quality of life. So this concept must not be very far from all of us, that these basic concepts, these fundamental concepts of IoT, or for that matter, the basic necessities in a city. So with these goals, with having discussed the definition of the smart city, it must be quite clear that the smart city goals are quite clear, that we are supposed to achieve a sustainable development, we are supposed to increase the quality of life of its citizens, and we are supposed to improve the efficiency of the existing and the new infrastructure. And all these things have, I think it has already been covered in the definition, but you can see that these are the primary goals of any smart city architecture or model which you might witness. But then again, to achieve these goals, and as I said, by utilizing the information and communication technology, the information and communication technologies plays a very important role in this, in achieving this dream of smart city or the goals of the smart city. So, the utilizing the information and communication technology, the traditional sustainable model. Now, this is the traditional sustainable development model which I am talking about. Now, this traditional sustainable development model can be easily modified to a smart development model, right? Now, smart development model, you can see there is not much difference between the two models. That is the sustainable development model, which is shown over here. Just a minute. And the smart development model, which is shown over here, right? So you can see that there is not much difference between the two models which is presented over here. But a significant difference you can see between the two models, and the first difference you can see is the technological factors which is introduced at this point, the human factors which is introduced at this point, and the institutional factors. Now, what are these factors? The technological factors, the human factors, and the institutional factors. Apart from the already existing model, apart from already existing components of the sustainable development model. Now, we shall discuss these factors in a bit detail in the next slide over here, but in this slide over here. But let me briefly go through what these are: the technological factors, the human factors, and the institutional factors. As you can see, that any technology which you might develop or which you might propose for the for improving for the use of the human beings, it cannot function to its maximum capacity unless the human beings or the persons who are involved in utilizing or using those resources or technology are fully capable or are fully educated about the advantages of those technologies. So you can develop a technology, you can develop a smart transportation system, you can develop a smart waste management system, a smart water management system, but then again the end users have to know the importance of that. So because of that, all these technological factors, the institutional factors, and the human factors, these are to be introduced in order to make the sustainable development model a smart model because of the human factors. Now again, coming back to the technological factors, see, the as we have already discussed that the resources which are available, they are limited. The people utilizing these resources are growing, and that too they are growing at a significantly higher speed. So that too, they are once these the technological factors. So in order to utilize these resources the optimized usage of these resources involves technological factors, and then there goes the institutional factors, which provide these three factors provide the fundamentals for the smart development model. Now, coming back to the smart city enablers, these are the technologies which enable any city, which differentiate any city from a smart city, or which differentiate a smart city from any of the cities which we might have seen. So, if we see this, then smart city enablers can be simply summed up as smart governance, smart economy, smart mobility, smart environment, smart people, and smart living. So, smart governance, smart economy, smart mobility, smart environment, smart people, and smart living. Now, this figure over here is basically, I'll explain this figure, these enablers in a bit, and you'll see the same enablers which I have highlighted over there are contributing to the smart city environment. And these enablers, these in smart living, smart people, smart mobility, and all these enablers are contributing to the smart cities in so many different ways. So I'll go through these enablers and how and what are their contributions to this one by one. So the first would be smart living. So the first would be this smart living, and smart living is what? The as we can see, the sewerage and sanitation, water supply, electricity, housing, citizen safety, and public open spaces, these all need to be addressed in a smart city concept, and that too with an optimized usage of the resources. Then again, smart people, as I said, any technology which we might propose is as good as the people using it. So the education and the health education and the health are to be addressed, and that to be they are to be made aware of these technologies, and uh, they are to be given proper education regarding joining these resources. Then again, smart mobility, as I said, the number of people, the number of transportations, the number of people is growing significantly, and hence the transportations. So these transportations, the public transportations, the even the roads, the traffic systems, all need to be optimized, and these need to be optimized with the help of information and communication technology. Again, this comes to the transport, traffic, walkability, all aspects related to the mobility. Then again, smart environment, we cannot blindly go and develop technologies and not consider the environment. Apart from using information and communication technologies in all these aspects, the one of the important goals of a smart city, or one of the most important enablers of a smart city, is the smart environment, where issues of pollution, renewable energy, reusability of these resources are considered, and basically it is one of the most talked about issue, and there are so many aspects of smart environment which is are under consideration from in many of the research universities, many of the research professionals. Then finally, it is a smart economy and a smart governance. Then again, these two issues are also of supreme importance, because with the help of technology, with the help of information and communication technology, these benefits of this smart city, or all these benefits, all the opportunities or all the development programs can reach to the mass. Am I audible? City of now.
Yes, sir. Continue.
Okay. So as I was saying, there are okay. As I was saying, the smart cities application areas are many, and all these enablers and all these. Is there a problem at my end? Anubhav, can you help me over here? Can you hear me just, or is there any connectivity issue? Okay. So okay then, as I was saying, the smart cities have different fields and different areas in which these enablers and these contributors can be applied. So, economic, the institutional, the habitat, and the citizen portion of the smart city is covered by governance, economy, mobility, and all these things. You can see that the smart city areas in which these can be applied are are shown in this chart over here. You can see that the governance, as far as governance is considered, the smart city areas which deal with this are participation, transparency, and public and social services. Similarly, for environmental conditions, it is network and environmental monitoring, energy efficiency, and all these things. So, having said this, there are certain smart city challenges which need to be addressed, and these challenges are in every aspect or each of the six enablers which I have discussed: the governance, economy, mobility, environment, people, and living. So these challenges are quite popular and quite obvious, because as you can see, for instance, the people. If you are talking about the challenges which we face in the concept of a smart city, the people who are considered, there are certain challenges such as the unemployment, the poverty, the aging population, the health concerns of all these people, the not having proper resources for not having proper education for using these technologies. So all these are challenges which need to be addressed in any of these aspects. Now, finally, I have a smart city architecture which I'll be discussing. So this figure shows the layered architecture, which is very popular in the concept of a smart city. Now, as you can see, it is a four-layered architecture. It is a four-layered architecture. The first one is the city layer. The first one is the street layer. The second one is the city layer. The third one is the data center layer, and finally it is the services layer. Now, the data flows from the street layer from over here. The data flows from the street layer to the city network layer and connects the data center layer where the data is aggregated. or normalize or virtualize. Now, if I have to explain this entire architecture in a bit detail, then the first layer which I am talking about is the street layer. It is basically composed of devices and sensors that collect the data and take action based on the instructions. Now, the second layer which I am talking about is the city layer. The city layer is the layer just above the street layer, as you can see here, and as you can see in the figure, that the city layer is just situated above the street layer, and the routers or the network routers and switches are deployed as per the size of the data of the city. All the data aggregation is basically done at this layer, and makes the data ready for the transportation. Finally, the third layer which we have is the data center layer. It receives all the data collected from the nodes at these levels, and it processes the data, and it processes the data for data correlation and everything. Based on this processing, in some inferences are derived, and finally the services layer is there, which identifies the services that can be provided. Now, you'll say what specifically how this services layer is utilized. You can see, consider this example where let us say data from a smart parking from a parking picture data from a parking or a smart parking is available to us. Now, let us consider this data, and we say that we have this data which indicates that certain spots in the parking spaces which are occupied and which are not occupied. Now, this same data can be used by different people in different ways. For instance, if you are using a mobile app for accessing this data, you will get to know what is the most perfect parking space available in a specific parking lot. However, the same data can be used by the city administrator, or the, let us say, the administrator who is controlling all the traffic on the road. The city administrator can redirect traffic on their own, not only individual car, not only one car or one vehicle. They can redirect all the vehicles in a specific area to a specific parking lot, or they can help a greater part of the population in general. Now, as I was having discussed these four layers of the architecture. Now, since I was talking about smart parking, I'll consider, I have also included the use case of a smart parking over here, where you can see that this use case presents a clear picture. I'll not go into the details of the smart parking use case, but consider this a general description about a smart parking is that a variety of parking sensors are available in the market. Now, sorry. A variety of sorry, as I said, a variety of sensors are available in the market. Now, consider the case of a in-ground magnetic sensor. It is one of the kind of sensors available in the market, and these sensors are battery powered, and they are event driven. Event driven means they are calibrated to react to the change in the environment. Now, since the events are not very frequent in a parking lot, the battery lasts for a significant time. So anyways, in such an environment, there are several gateways that can connect to the parking sensors. Then they can use short-range communication protocols such as Zigbee. Now, these gateways can then connect to the local station using any of the standard mediums. Then these mediums can be wired or wireless to transfer their data to the end user and to the central processing unit. Now again, there is a use case of a smart transportation system, which I was hoping to discuss. I'll quickly discuss this because I need to cover one more topic, which is of importance to me as well as for all the researchers who are over here. So, smart transportation is again then a transportation system which is capable of providing certain facts and figures, such as the tracking of the health of the vehicle, the tracking of the status of the vehicle, the tracking of the health of the the road conditions, the traffic lights which are involved. The smart traffic lights can be incorporated. Now, health of these devices can be incorporated. Now, there can be information management systems, there can be security surveillance systems, there can be there are materials which are included into while in the construction there in the construction of the road, during the construction of the road itself, to generate heat maps, which will effectively help us in generating identifying the specific traffic density at at a specific instance at any day of the time, any time of the day. Similarly, there are with surveillance systems, we can have each alarms, and we can have security, all the issues of security addressed from over there. So all these things can be included with the help of a smart transportation system, and all these the things which I have just said, for instance, the health monitoring system of vehicles, the smart traffic lights, the passenger information system, the surveillance systems, the heat map, and the activity generation system for a network traffic. All these are the possible actors in the use case of a smart transportation. Now, when we talk about the security and the threat analysis in a smart city environment, it is basically, I'll discuss one of the many applications. The figure over here, this is an image of a integrated command and control center in Bhubaneswar, where where this center is responsible for monitoring and detecting monitoring and detecting any and all the activities which are happening over the city and are being monitored by the surveillance systems which are placed. Now, the integrated command centers are in Vishakhapatnam and Bhopal, but these are not of importance. I was just showing those figures because this is what integrated command center of a surveillance system would look like. Now, coming to the research problem which I'm trying to get to is basically based on surveillance systems, which is derived from from this problem of monitoring these events, or monitoring the happenings, or monitoring the anomalies which these surveillance systems might witness. Now, as I'm saying, this problem is of detection of important events. And when I say important events, it is not like a event, because consider the case where a surveillance system is deployed to monitor and track the events happening in a in an environment, in a whatever surveillance system is might be deployed. Now, you see that the number of people passing through the surveillance system are many, and the events are many. The number of events passing through these surveillance system, or the number of events which this system is reporting, is many. But what happens is, what is of importance is that we have to also track we have to check the anomalies which might be reported, but they might not be considered by the system because they are a random events which are not fitting into a pattern, right? So what a anomaly in a surveillance system can be, 20 events being reported, and let us say these are 15 is there a connectivity issue? Can you hear me?
Yes, sir.
Okay. So consider, as I was saying, let us say the 15 events they were reported correctly, but the 16th event, let us say one of those events was reported, but the system thought that it is an anomaly and should be discarded. So this entire work which I am going to discuss is
Sir, your voice is not audible.
yes, okay, the people are saying that they can hear me.
Now you are
Okay.
audible, sir.
So, okay, as I was saying, distribute that I'll quickly go through the distributed inference which we have proposed. As I was saying, if there is an anomaly and that needs to be detected, right? So, if in such a scenario, what is which we have considered? We have considered the anomaly to be, let us say, see that it is actually basically the time of the existence of the event, or the time until which the minimum time for which the event has to be valid. For instance, if you see there is a, let us say, mark let us consider the example of an animal tracking. Then if you see, if animal appears into the frame of a surveillance system, then there must be a minimum time frame for which the animal will be present. Or consider it an example of a traffic surveillance system. Let us say a truck is, yes, let us say a truck is passing by let us say a truck is passing by a video surveillance camera. What happens is that there must be a minimum time frame of, let us say, 2 seconds. Let us say for 2 seconds this truck will be visible in the video camera, right? Now if this 2 second is considered as the persist can be considered as the persistence period for a truck. बहुत बड़ा सा truck है, मान लेते हैं there are 10 or 20 tires involved in that truck, and the length of the truck is quite long. So for a truck moving at a speed of 40 kilometers per hour, the time frame can be, let us say, 2 seconds or 3 seconds for a camera. So this 2 or 3 seconds can be the persistence period for the existence of that event, that if a truck is reported in a specific frame, then it will be present for the next 3 seconds, right? Let us say the event frame is of 5 seconds and the persistence period is of 5 seconds. Then once the event has been reported, it will be reported for the next 5 seconds also, right? uh, uh, and if that is the case, let us say if for any other event that this persistence period can be of, let us say, 2 seconds, or can be of 1 minute, or for that matter, any kind of different kind of events can have different kind of persistence period. For instance, in case of a fire, what will happen in case of a fire? It is not the case that fire will suddenly light up and then will go out. It is not the case. If a fire is reported, it will be reported for a certain duration. If you light a matchstick, then it will be reported for at least, let us say, 2 seconds. After 2 seconds it might go off, or it might continue to burn, but the minimum duration will be of 2 seconds. So considering that, we considered the persistence period of every event, and the persistence period of such events, and we said that, or we assumed, or we detect the event detection model was defined to be a binary sensing model, that is 1 or 0. If the event is reported 1, then it means the event is occurring, yes, and if 0, if there is no event reported. So as per the discussions which we just had, you can see that the if an event occurs, then the event will be reported either 1 1, because let us say the persistence period is of 2 seconds. Then it will be reported 1 1, or if it is not reported at all, it will be reported 0 0. So these are normal events, right? But what is of importance to us is 1 0. The event was reported in the first frame, but it could not be reported in the second frame because of certain reason, because of the node loss, because of the link loss, because of the data loss, or whatever might be the reason. But the event was reported in the first frame, but it was not reported in the second frame, because, and this is a anomaly, or this is a event which we are interested in. Similarly, if a event is not reported in the first frame, but it is reported in the second frame, then again this is of importance to us. Thus, for addressing these issues, or for monitoring these events, we activated more in wherever this case happens, spatially correlated observations from these targeted regions is obtained, and these spatially correlated uh, spatially correlated are processed with the help of are transmitted to the base station processing unit with the help of compressive sensing method, which we have worked on quite frequently. And this compressive sensing method was used to transmit the data for transmitting the data to the base station. And finally, we tested this entire mechanism and this entire solution on certain parameters such as accuracy rate, rate of true positive, false alarm rate, and area under coverage. Also, we tested the our proposed algorithm on a set of experimental database, and we obtained significantly better results as compared to many of the existing methods. We also simulated the entire solution in a simulation setup, and we obtained the in network transmission heat map, which you can see in the figure shown over here. The in-network transmissions is quite uniform because of the compressive sensing method which we use for data transmission. Because of the in-network data transmission and the optimized in-network data transmission, because of the compressive sensing, the network lifetime, you can see the proposed scheme is able to achieve much better lifetime. However, as far as the main objective of the paper is considered, or the work is considered, these are the factors which we were primarily interested in: accuracy rate, rate of true positive, false alarm rate, and area under coverage. As you can see, the accuracy rate as shown over here is significantly high. It is approximately 99.02, which is basically almost the highest, a very high accuracy rate. And then again, not only the accuracy rate is high, but the false alarm rate is significantly low, is very low. And this then solves us the entire purpose of accurate event detection. We also ran a comparative evaluation of the runtime of the algorithms, and the proposed algorithm was able to outperform the existing approaches there also. And finally, to conclude this entire presentation, I would say that the Internet of Things and the wireless sensor networks have evolved into the. I'll be open for questions just a minute after this concluding remarks. So, okay. As I was saying, the Internet of Things and wireless sensor networks have evolved as one of the most prominent technologies which we are using nowadays. So these technologies, not only these technologies, but these technologies in combination with techniques of machine learning, deep learning, and various other techniques, they can be used to address several issues and optimize the performances of so many existing solutions. So it is a vast field and diverse field, and they can be used in so many different ways to optimize the lifetime, the natural experiences of our day-to-day life even. So that will be all from my side. I'm open for questions. And all the this paper which I was referring to, this was published in 2018 in IEEE Systems General, along with Dr. Manish Kumar and Professor Shekhar Verma. They were my Dr. Manish Kumar is my PhD supervisor as well, and Professor Shekhar Verma was also one of the co-authors in this. And so this paper was published in IEEE System Journal in 2018. All the figures and other references are taken from this book of Cisco, IoT Fundamentals, Networking Technologies, Protocols, and Use Cases for Internet of Things, which is authored by David Hens and et al. So I'm thankful to the authors of this book, and thankful to my co-authors, Dr. Manish Kumar and Shekhar Verma, for working and suggesting the way of these to address this problem. I'm open to questions.